This is the video notes for Unit 4, Lesson 3, Solving Equations Literally. It starts with a notice and wonder, and it says solve each of the following equations for x. So before we start solving, I want us just to look at the equations and see if we see any patterns, if we're noticing anything. The first thing that I'm noticing is that equations 1 and 2 look very, very similar. Right? They look pretty much the same, except in equation 2, on the top, instead of just a 2, it has a 2y. So that's interesting. It has an extra variable. Let's look at the next ones. So it looks like 3 and 4 are pretty much the same, except for in 4, the minus 5 has a y attached to it. Interesting. Okay, let's look at 5 and 6. Those pretty much look the same, except for instead of x plus 3, it's x plus y. Okay, and then 7 and 8. Again, I'm seeing some y's in number 8 that are not in number 7. Do you see here? Instead of 4, it's 4y. Instead of 12, it's 12y. So we're going to go through and solve these, and I'm wondering what difference the y will make in the even number questions 2, 4, 6, and 8. So that's my wonder. So I noticed that they all have an extra variable in problems 2, 4, 6, and 8, and I'm wondering how it affects our answer. So let's go through, and we're going to solve 1 and then 2, and then talk about it in 3, 4, and talk about it, and so on. Okay. So, number 1, it looks like we have 3x plus 2 divided by 5. The last thing I said was divide by 5, so that is what we have to undo first. To undo a division by 5, we're going to times both sides by 5. On the left side, the 5's cancel out. We have 3x plus 2 left over. On the right side, we can multiply 7 times 5 and get 35. Now we've got 3x plus 2. The last thing I said was the plus 2. So I'm going to undo that next by minusing 2 from both sides. So I'm going to get rid of the 2's on the left. I have 3x left over, and on the right I have 33. Okay. Now on the left I have 3x. That's 3 times x. How do I undo a times? I need to divide. So that will get rid of the 3's on the left and just have x left over. On the right, I'll also divide by 3, and I'll end up with an answer of 11. Okay, now let's look at number 2 and see how having a second variable changes things. So I have 3x plus 2y divided by 5. The last thing I still said was divide by 5, and I'm still solving for x. So I want to times by 5 to get rid of the divide by 5. I have 3x plus 2y equals 35. Okay. 3x plus 2y. So again, the last thing that happened to the x was the plus 2y. So I'm going to minus 2y. That gets rid of it over here. I have 3x left over. And here on the right, the 35 and the negative 2y are not like terms. I cannot subtract them from each other. So I'm just going to write them next to each other. 35 minus 2y. 3x, so that's 3 times x. How do I undo that? I just divide by 3. That gets rid of the 3 in front of the x. Have to do the same thing on this one. So I'll end up with x equals an expression rather than a single number answer, one solution. So I have 35 minus 2y divided by 3. If I knew what y was, I could plug that in for y and actually come up with a number answer, but since I don't, I just leave it as is with that second variable on the right and x by itself on the left. So let's talk about what we're seeing. Okay, number 1, only one variable. We were able to solve it fully for x, and we got 11. Number two, two variables. We also were able to solve it fully for x, but we didn't get a number, we got an expression, okay, which still has a variable in it. Okay, let's see if that happens also in 3 and 4. So number 3, we have 4 times x divided by 3 minus 5. Last thing I said was minus 5, so I'm going to undo the minus 5 first. Add 5 to both sides. That goes away. I have 4 times x divided by 3 equals 16. Okay, now 4 times x divided by 3. Divided by 3 is the last thing that happened, so I have to undo that next. So I'm going to times by 3 on both sides. I'm going to have 4x equals, 3's cancel out. This is 30, 48, I believe. Okay, 4x, that's 4 times x, so I'm going to undo that by dividing by 4. Dividing by 4 on both sides. And then I have x by itself, and I have a number, a final solution of x equals, I think it's 12. Okay, let's go ahead and see how we solve the same problem, but number 4 with an extra variable in it. Okay, number 4. In number 4, 4 times x divided by 3 minus 5y. Again, the minus 5y is the last thing, so I'm going to add that to both sides. Plus 5y plus 5y. Because I added 5y to the left, and the minus 5y goes away, it adds up to 0. I still have the 4 times x divided by 3, but on the right, I cannot add these two things. The 11 and the 5y are not like terms. One is just a constant, one is a variable with the y, so I just have to write them next to each other. 11 plus 5y. Okay, and then I ask myself, okay, now what do I have to undo next? 4 times x divided by 3. Oh, the divide by 3 I have to undo. So I'm going to times both sides by 3. That goes away. I end up with 4x equals. Now, when I times the right side by 3, it wasn't just the 5y I was timesing, it was the whole thing. So I need to add some parentheses in here. I like writing something like this with the 3 in the front. 3 parentheses 11 plus 5y. Looks a little cleaner. Okay, last thing to undo is the 4 times x. So we undo that by dividing both sides by 4. So I end up with x equals an expression this time, which is what happened in problem 2 as well. So I have 3 parentheses 11 plus 5y close parentheses, that whole thing divided by 4. Okay. All right, what am I noticing? Again, number 3 gave me a single constant as my answer, but number 4 gave me an expression just because of that extra variable. If I knew what y was, I could evaluate, I could plug in my value for y in number 4, but since I don't, I just leave it. All right, let's try 5 and 6. 2/5 times, parentheses, x plus 3 equals 6. Okay, so in this case, the last thing that happened to the x is not the plus 3, it's the timesing by the 2/5. So I need to somehow get rid of the times by 2/5. So I can do two things. I can divide by 2/5, or I can multiply by its reciprocal. A reciprocal of a fraction is just the same fraction but flipped. So I think I'm going to do that. So I'm going to times by 5/2 on both sides. What that does on the left side is it makes the 5's cancel out and the 2's cancel out, so that 2/5 is gone. I end up with x plus 3 on the left, and then on the right, this is like 6/1. I just multiply across and then simplify. So this is going to be 6 times 5 is 30, 1 times 2 is 2, 30 divided by 2 is 15. Okay, now x plus 3, got to minus the 3 from both sides to undo that. Okay, cross that out. I have x equals 12 as my final answer. Okay, so again, a constant as my answer, not an expression, which is what I expected since I only have one variable. Let's see how to solve number 6. So number 6 has 2/5 times the sum of x plus y, and that equals 6. So I'm going to get rid of that 2/5 first again by timesing it by the reciprocal, so by 5/2. By 5/2 goes, the 5's go away, the 2's go away, then I have x plus y equals, and I already did the math for this on number 5, so that's 6 times 5 is 30, divided by 2 is 15, okay? Then I have to undo the plus y next, so I'm going to minus y from both sides. The y goes away, I end up with x now by itself, which is what I wanted, solving for x, right? And then since the 15 and the minus y are not like terms, I cannot subtract them, cannot combine them. I'm just going to write them next to each other. Okay, again, because of that extra variable, I end up with an expression as my answer, not as a constant, not a single number. All right, let's see if that also happens in 7 and 8. So number 7, we've got 2 times the sum of 3x plus 4 equals 4x plus 12. So whenever we have parentheses, we need to get rid of those first. So we do that using the distributive property, right? We're going to multiply that outside 2 times everything inside the parentheses. 2 times 3x is 6x, 2 times 4 is 8. And then on the right, it remains unchanged. Now we want to group all the like terms together. So we're going to move things across equal sign using addition or subtraction to group the things that are the same. So I want to get this 4x to be with the 6x. To move it away from the right side, I'm going to minus 4x from the right. Have to do the same thing on the left. 4x minus 4x is 0. I just end up with 12 on the right. On the left, 6x minus 4x is 2x, and I still have the plus 8. Okay, now this is a two-step equation. 2x plus 8, so I'm going to minus the 8 from both sides. Undo the plus 8 by minusing. That goes away. I end up with 2x equals 4. 2x, that's 2 times x, so I'm going to undo times by division. 2 divided by 2 is 1. 1x is just x, so x is 2. Okay, so number 7 just had one variable in it, which we were able to solve and get a single number answer. Let's see how adding a second variable in number 8 changes things. So here's number 8. We are going to start off by distributing again. That's just a good way to get rid of parentheses and start simplifying. So we have 6x plus 8y this time. We still want to group the things that are the same on same sides. So I'm still going to move this 4x to the left by minusing 4x to both sides. 4x minus 4x is 0. 6x minus 4x is 2x. You notice I put the minus 4x under the thing that is the same as it, under the 6x. That's kind of important. Sometimes students don't know to do that. We still have the plus 8y, and on the right we still have the 12y. Now we want that 8y to move to the right side to be with the 12y, right? So we'll do the opposite of adding. 8y will minus 8y from both sides. That adds up to 0, so we can cross it out. And then we have 2x equals, and it looks like we've got 12y minus 8y. Those are like terms, so we can actually subtract them. That'll be 4y. Okay, to finish up, we'll undo the 2 times x. So we'll do division to undo it. So we're going to cross that out. 2 divided by 2 is 1. That's just 1x or just x. And then I can actually divide the 2 into the 4 and get 2y. Okay, so the steps basically were the same. Have you been noticing that? The steps are pretty much the same for all of these pairs of problems. Like for 7 and 8, I distributed first in both of them. Then I moved the 4x to the left side using subtraction, using the subtraction property of equality for both of them. And then I minus 8 or minus 8y using, again, the subtraction property of equality. Same step. And then divide by 2 at the end. That's the division property of equality. Exact same step. So one gave me a constant, a single answer, and the other one gave me an expression, but they used the same steps. All right, let's move on to number 9 and 10. Write a verbal description for each step of the equation solving process used to solve the following equations. For x, your description should include statements about how you know what to do next. For example, you might write, first I did this. The reason I can do this is because of. All right, so this one wants us to identify the properties that are being used each time we do a step in our solving process. We're actually just going to solve number 9, so it's okay for you to cross out 10. So let's cross out 10. And it looks like we're solving for x, so the x is right here. It's kind of buried in the equation. So we need to undo a lot of things that are happening to it. It has something timesing it, so a times x. It has something adding to it, plus b, has something being divided, divide by c, and it also has a subtraction, minus d. So a lot going on. So we're going to break it down into every single step and then give the reason we were able to do that. So I'm going to rewrite it over here. So we say ax plus b divided by c minus d equals e. So the very first thing that I'm going to undo is this minus d. The reason I'm undoing that first is like the furthest thing from the x. It's the last thing that happened to the x. So in order to solve for x, I need to undo the last thing first. So I'm going to add d to both sides. That'll be my first step. Goes like that. Okay, so minus d plus d, that's 0, so I can get rid of it easily. X plus b divided by c. And then over here on the right, they're not like terms. E and d are different. I don't know what they are, but I can just write them next to each other. And that's okay. The next thing I need to undo says a times x plus b divided by c is that divide by c. So I'm going to times both sides by c. That goes away. You'll notice on the right side, it's not just timesing the d by c, but it's timesing both. So I need to add in some parentheses. I end up with ax plus b equals, and I like to write the c in front of the parentheses. It's just a little cleaner. The next thing that we need to get rid of is that plus b, because we have a times x plus b, so the plus b is the next thing. So we're going to do the opposite. We're going to minus b from both sides. The b's go away. We end up with ax equals c times e plus d minus b. We're just going to put the minus b at the end because it has no like terms to it, so we'll just put it after the parentheses. The last thing we need to get rid of is the a times x. So how do you undo a times? You divide. So we're going to divide both sides by a. A divided by a is 1. 1x is just x. We have solve for x. So x is the expression c times e plus d minus b, that whole thing divided by a. Okay. Now we're going to go through and justify, like give a reason why we were able to do each step using the properties of equality. Okay, so let's go back here to the top. So first, I added d to both sides. And the reason I could do this was the addition property of equality. So we're going to write that right here. First, zoom in a little bit more. First, I added D to both sides using the addition property of equality. Okay, then second, we multiplied C on both sides. Second, I multiplied C on both sides. So this was first, here's second. Using the multiplication property of equality. And remember, I choose which property to use based on what's happening to undo what's happening. Okay, let's go to our third step. So our third step, third, I minus B from both sides using the subtraction property of equality. That helped me undo an addition by doing the subtraction. Okay, and then last, I divided both sides by A. Divided both sides by A using the division property of equality. Okay, so those were the steps to solve this literal equation. That's what this is called, where you have no numbers or very few numbers and mostly just letters. Okay, let's go ahead and fill in our takeaways. So the takeaways are a whole bunch of properties that kind of help us in our solving process. The first ones are for addition. So for addition, we have an additive identity. So what that means is, there we go. If we add 0 to anything, it doesn't change it. So let's say I have A and I add 0 to it, then that just will add to A. Additive inverse, so let's say I add things that have opposite signs. They will add up to 0. Commutative is like the order. So let's say I have A plus B. That's the same thing as B plus A. And then associative is how you group things with parentheses. So let's say I have A plus, and then the B and the C are grouped with parentheses. Well, I can just change that and have the A plus B grouped with parentheses and then the C by itself at the end. Okay, so those are properties of addition that we need to know. Properties of multiplication. There's a multiplicative identity that says anything times 1. So like 1 times, let's say A, is just itself, it's just A, no change. Multiplicative inverse means that if I have a fraction, let's say A over B, and I times it by its reciprocal, B over A, that just equals 1. So that's really helpful when I have fractions. Commutative, again, has to do with order. So A times B is the same as B times A. And then the associative has to do with grouping with parentheses. So if I have A times parentheses B times C, That's the same as A times B in parentheses and times C by itself on the outside. The last property we need to remember about is the distributive property. That's when we have a letter on the outside being times by a sum on the inside, or a subtraction on the inside. Could be adding or subtracting. The way that you simplify this is you need to multiply this outside term by everything inside. So you end up with, instead of B plus C, you end up with A times B plus A times C. Okay. So those are the takeaways for lesson 4.3. In this lesson, we compared strategies for solving linear equations and literal equations and found that the processes for solving each are similar. Both solve types of equations using inverse operations in the reverse order from the order used when evaluating the expression. However, the answer to a linear equation is just a number, while the answer to a literal equation is a variable or an expression. Sometimes we have to combine like terms, particularly if expressions contain the same variable occurring on both sides. Properties of and operations of properties guide our thinking when solving equations and help us justify each step in our equation solving process. Okay, I'm hoping that was helpful, and I wish you good luck on your practice.